now we're going to look at line segments and their measure. This requires us to use the real number line. Let's quickly go review what a real number is. So a real number includes rational and irrational numbers. And rational numbers include integers, and integers include whole numbers, and whole numbers include natural numbers. So let's give an example of what a natural number is. Natural number we also can call as counting numbers. These are going to be 1, 2, 3, 4, etc. Whole numbers include all of these natural numbers, and they also include 0. So a whole number would be 0, 1, 2, 3, 4, etc. Integers are numbers that include negative, natural, and whole. Integers. So we have our whole and our counting, but we also can include now these negative numbers. Rational numbers, these are fractions. They're terminating fractions. For example, 1/2 will give us 0.5. 1/4 will give us 0.25. And you can also do negative 1/2 equals negative 0.5. And negative 1/4 equals negative 0.25. Irrational numbers, on the other hand, are numbers like pi, which is a number that is non-terminating. It never ends. Or the square root of 2, or the square root of 5. In the contents of this course, we will be looking at all real numbers. The next postulate is going to be the ruler postulate. And this states every line can be made into an exact copy of the real number line using a one-to-one correspondence. Let's start by drawing a line. Say this line keeps going to the right and to the left. We'll call it L. So let's say line L is labeling all the real numbers using the ruler postulate. The real number associated with a point on the line is called a coordinate of that point. So if we draw another line here, and let's choose integers, 0, we choose a point right here, let's call it A. We're going to say that A is labeled as 3. So the coordinate of point A is 3. You should also note that this line L that's representing the real number line is infinite because there are infinitely many numbers on a real number line. Next we'll look at distances between coordinates. So here's another infinite line. And we'll draw we'll plot some integers. This would be so we'll pick a point. Let's call this point A and this point B. Now we want to know the distance from A to B. So we're looking at measuring the distances between points using coordinates of the points. So we're looking at a non-negative difference between these coordinates. So let's start with the distance would be 3, and we'll subtract from where we started, minus, we started at -2, and when you subtract a negative number, that's the same as adding. So this becomes 3 plus 2, which equals 5. So the distance from A to B is 5. Let's check that. We start at -2 and we go 1, 2, 3, 4, 5. Or you can start at 3 and go backwards. 1, 2, 3, 4, 5. So what a line segment is a part of the line bounded by two distinct points, or bound by two distinct points. So if we want to know the line segment here for AB, he actually can go from A to B, and it's bounded by A and B. So we would call this that would be the same as line segment AB, where it starts at A and it ends at B. And these are 2 points on this line, L, where the line segment is determined by A and B. We can write this AB with a line over it, or BA. It means the same thing. This line segment AB is the points A and B together with all points on the line whose coordinates are between A and B. Points A and B I'll call the endpoints of the line segment. 2 endpoints. The length of line segment AB can be written AB or just AB is the distance from A to B. So earlier we calculated the distance from A to B is 5. So you can just write AB equals 5. So if we continued on our number line, and we found point C here, point D here. Let's look at the distance for line segment CD. 1, 2, 3, 4, 5. You can count, or you can go from one end and subtract from the other. 11 minus 6 equals 5. When line segments are the same, have the same distance, they're considered congruent. So we would write that as line segment AB is congruent to line segment CD. Or, thinking of it as distance, the distance AB is equal to the distance of CD. So you draw that, say this is A and B, line segment, and this is CD. In order to determine or to denote that they're congruent, just put a line through it. That means that the distance between AB and CD are the same. The last line I want to talk about is a ray. So a ray is just a portion of the line that has one endpoint and extends indefinitely in another direction. This is point A and point B. This would be called ray AB because it starts from A as its endpoint and it goes on towards B direction indefinitely.